Hey everyone, welcome back to the shop. So I've been playing around a little more with this trying to make a Mikrokator thing. Just got a couple of quick updates on how that's going, progress and challenges that need to be worked on. I'll just go through them list-wise. So first thing is annealing, right? So a very important part of the process when making these twisted strips is to relieve the stress from that strip. You twist it up, but then you need to anneal it so you're not in this, it's not like a wound up spring anymore from when you twisted it. It needs to be in a resting state in this twisted configuration. The way I was doing that before was just with a hot air gun, trying to sort of anneal it more or less evenly and on either side and get it up to a temperature where the material relaxed and it stopped having this stored spring energy. This was terrible. It's not even at all. And what would happen is, and you probably will not be able to see this on this ribbon here, but when you locally heat one area too much, the twists, which were previously nice and evenly distributed across the length, they sort of bunch up and group together. So they'll be like, you know, one twist over the course of, say, a half an inch or so, and then 3 twists all in a 1/4 inch. And this is obviously not ideal. The revelation I came to there was kind of an obvious idea, kind of dumb for not thinking of it sooner. Electrically anneal them, just pass a current through the wire, right? Duh. So this is, I use this in multiple steps. The first step is you get the raw round wire off the spool and blast it with 0.6 to 0.7 amps, and that not only anneals it mechanically, but it also blasts off the insulation, the enamel that's on this wire, because we don't want that around. So that just sort of flashes off in an instant. Then you do the rolling, you do the twisting, and then pass another 0.6 or so amps through it to again bring it up to that annealing temperature to pull the stress out of it. Really works great, super even and consistent, so that's a win. Second, rolling. So making the rectangular strip itself is sort of the main sticking point that's holding me up right now. If that's not consistent, or if I'm not able to do it consistently enough and with enough control to where I can sort of, you know, experimentally like run through a set of tests, then it's making things very difficult that I can't do that right now. One thing that's helped and is going to help more, my buddy Adam the machinist ground this cool roller for me here. This is just a 10mm dowel pin, but the area between these 2 relief grooves here, the center diameter, that's smaller in diameter than the 10mm outside by around, it's like 18 microns last I measured. And so what that means is there's a step on one side, there's a step of around 9 microns. So we can sort of use this as a deterministic roller, and if we just run it over a surface like this with the wire underneath it, in theory we're left with a around 9-10 micron thick band, and that works pretty consistently. Now it's still not good because, or the results still aren't great, I should say, because, you know, look what I'm doing here. This is not a very controlled process. Any little movement of my hands that twists it, or if there's a little bump on the surface or a piece of dirt, the thickness locally changes. It's not ideal. So I am designing a little miniature rolling press that that will accept these roller pins. I'd like another one that's only a 5 micron step. It seems that that's probably going to be necessary to get to the levels I want. But this is a great idea. So thanks to Adam for making that, sending it along. So the glass pointer is another one. Last video I showed using a bare glass fiber from a fiber optic cable as the pointer. And as small as that was still way too big, way too heavy, had way too much rotational inertia. So this is what I've moved to now. Now these still are going to be too big for the sort of final thing I have in mind, but they're a great improvement. So these are glass capillary tubes between 0.2 and 0.25 millimeters ID. So the OD, it doesn't actually say on the package here, but as best I can measure, they're around 400 microns. So these are actually around 40% larger than the glass fiber that I used in the last video. So that sounds bad, right? But the cool thing about engineering is these are tubes. So even though it's 40% bigger in diameter, it's half the weight of the glass fiber, the solid glass fiber, and it's 3.6 times as stiff as the glass fiber. So that's awesome. It's really important. You can see how much stiffer it is just touching it here. Obviously still pretty bendy, but this is much closer to what will be necessary for an actual Mikrokator pointer. All right, and here's the current test rig for the test ribbons. So this is one that I made with that new roller. Like I said, around 10 microns thick. Best I can measure, because it's kind of impossible, around 150, 170 microns wide. And we've got 4 twists in the ribbon. It's actually 4 on this side and 3 on this side, because this, of course, snapped, and I've moved the nut to a new location, but we lost a twist. But you know, good enough for testing, right? Anyways, I can actuate the micrometer screw back here to move this left block, and as I do so, you can see the pointer twist in the middle. So cool, it works. What I have noticed though is this, so these low number of twists, in theory it's more sensitive. The less twists you have, the more sensitive this, but the more angle you get out per displacement of the one of the stops, one of the blocks. Same goes with the width of the ribbon. The narrower the ribbon, the more sensitive in theory as well. But there's less range. So what happens if I travel too far is the ribbon will yield somewhat, and then it won't return back to 0 again. So this particular sample here only has, it's not even 90 degrees of range before it yields. And unfortunately, it's still not quite as sensitive as I'd like. You can see, maybe you can see in the background, the electronic indicator needle moving. And funnily enough, the ratio is almost 1-to-1 between the glass pointer and the needle on the indicator. So this is, it's too blurry, but we're looking at the top scale. It's plus or minus 3 thou. So the ratio I'm getting here is maybe 2 thou every 30 or 45 degrees of the ribbon. So really not super great. You know, if you think about some normal indicators and their ratio of displacement to angular movement, because that's really what determines the magnification, right? Just an interrapid like this is 90 degrees per 2 thou, and you go further to a millimess or something, and it's 180 degrees. It's actually over 180 degrees for 2 thou. So this actually, while this is neat and a cool way to measure displacement here, this is not nearly sensitive enough to be anything impressive. So I need to keep tweaking the parameters of the ribbon until we get a result that's good. But without a way to do that even a little bit consistently, it's sort of all for naught. So the main focus now is working on a rolling press where I can create ribbons of known dimension and do that pretty reasonably consistently. So yeah, that's the update there. Thanks for watching.